The overall goal of this procedure is to prepare gold nanoparticles that are overcoated with a wide bandgap semiconductor shell. The shell material can be either cadmium or zinc sulfide, and the thickness should be tunable.
This technique overcomes the large lattice mismatch between core and shell by using a 4-step cation exchange technique to form the shells. The main advantage of this technique is the ability to produce highly monodisperse gold core shell nanoparticles with excellent control of the shell thickness. The nanoparticles produced with this technique could be used as plasmonic elements that couple with absorbers in optoelectronic systems because the wide bandgap shell enables precise tuning of interaction distances. Tuning interactions in this way enables us to limit losses and maximize absorption or emission gains and provide insight into the potential of exciton-plasmon coupling for a range of applications.
To begin synthesis of gold nanoparticles, work in a glove box to weigh gold salt in a vial previously cleaned with aqua regia, before diluting with 100 milliliters of water in a volumetric flask. Then, add 3.2 grams of solid cetyl trimethylammonium chloride, or CTAC, and heat in 25 milliliters of water to approximately 60 degrees Celsius for dissolution. Cool the mixture to room temperature and dilute to 50 milliliters with water in a volumetric flask to prepare a 0.2 molar CTAC solution. Mix 20 milliliters of 1 millimolar gold solution and 20 milliliters of 0.2 molar CTAC solution inside a round-bottom boiling flask. Allow to mix in an oil bath set to 60 degrees Celsius for 10 minutes. Next,